All right, it looks like we're all ready to go. So I'm very excited to welcome you to the Civil Engineering Doctoral and Master's Program online information session. This is actually a really happy day for me because I've been at Johns Hopkins for about 6 years now, and I love to share what I love about Hopkins. So without further delay, we'll get right into it. So first, a little bit about me. My name is Swaleh Siddiqui. I am Director of Graduate Studies in the Department of Civil Engineering. That's mostly why I'm talking to you today. And I'm also Assistant Professor of Civil Engineering and Co-Director for the Center for Systems Science and Engineering. With me today are 4 of our students. So we'll go on and now they'll introduce themselves one by one, starting with Haralampos.
Hello everyone, I am Haralampos Avram, and my advisor is Swaleh Siddiqui, and our work revolves mainly around developing equilibrium models to understand the interactions between the energy and the food system.
Hi everyone, my name is Max Pins. I am my advisor is Somnath Ghosh, and we work in modeling real-world systems, and I work in description of nickel-based superalloys and how to model them.
I'm Astrid Fisher. I'm working with Ben Schaefer, and my research is on optimization of steel diaphragms for better performance of those under earthquakes.
Yeah, hello everyone. My name is Enze. I'm a master's student from civil engineering. I'm working with Star Wars, and my research area is 3D print lattice and DNA nanostructures.
Great, thanks everyone. So as we go on, if you have questions for me or any of these wonderful students or any of our staff who are also listening in, please feel free to type them in the questions box, and we'll try and get to them towards the end of the presentation or email you answers afterwards. So what we'll do is we'll start off with an introduction of Johns Hopkins Engineering and why you would think about this school as a whole. We'll get a little bit overview of our program and the Department of Civil Engineering, go through some of the nuts and bolts of the admissions process, and then spend some time on the research areas and student experience. And then finally, we'll finish with a question and answer session at the end of the presentation. So why engineering at Johns Hopkins University? One of the things that a lot of people don't realize is that Johns Hopkins by far is the leader in the United States for federal funding. So we received a record $2.43 billion in fiscal spending in 2016, and this is for the past 38 years. We are by far ahead of any other university. If you look at the second place university, we're almost double of the University of Michigan, Ann Arbor. So if you want to think in terms of research leadership and funding, Johns Hopkins is the #1 institution in the United States right now. And this shows in a lot of the research initiatives that do go on at Hopkins. So along with the research and the industry partnerships, you'll be able to see that Hopkins provides a unique experience when it comes from this perspective. So the Whiting School of Engineering looks to provide an education that's innovative, rigorous, and prepares our graduates to be leaders for the future. We have 25 research centers and institutes. One of the things that'll tell you is that Hopkins is incredibly collaborative. This is by far the most collaborative university I have seen around the world. And the presence of these centers and institutes supports those collaborations as we move across departments and traditional silos. Our expertise has been sort of divided into 3 broad areas that again interact with each other very carefully. So one is obviously medicine and engineering. We work very closely with the Johns Hopkins Hospital and the Johns Hopkins Medical University. We have several institutes and leadership initiatives in data science. And then finally, one of the ones most relevant to this department is that the idea of resilient systems and thinking in broader terms of society, what that means and how we can improve understanding of those. So without further ado, I'll dive a little bit into our Department of Civil Engineering. One of the things I want to point out is that one of the things I'll point out in our department have broader support in the Whiting School as well. So when I talk about our initiatives in terms of helping you get jobs of our career fair, are some of our entrepreneurship initiatives. Those are also broadly supported in the Whiting School as well. You can definitely find more information on those on the website. I'll be talking from the perspective of civil engineering, but please do ask us if you have any questions about the broader Whiting School initiatives as well. So our department, we have 12 engineering faculty, and added on to that, we have 5 lecturers and part-time faculty. We have around 6 postdocs at this time, 25 master's students and 48 PhD students. So if you look at the broader landscape of civil engineering departments, one thing that you'll see is that our department tends to be on the smaller side than other departments. The advantage of this is that, one, everyone knows your name. So anyone who comes into this department, we know the faculty, the lecturers, the postdocs, and the students know everyone really, really well. We tend to be a very, very cohesive unit who try and make sure that individually everyone succeeds. The other aspect that becomes with a small department is that you'll see that all of us individually are leaders and experts in very specific fields that we feel are very, very important for the next generation. So instead of finding, as in other departments, where you would find 5 faculty that might work on concrete, over here you'll find individual faculty that are leaders within large sub-areas of civil engineering. Despite being a small department, one thing I will say is that our department tends to have facilities of a large department, which the picture you see here is something we call the big blue baby. I've been around civil engineering departments all over the country and the world. I have yet to see a facility, a structural engineering, and you can tell I'm not a structural engineering expert. I've yet to see a structural engineering device that is of this level and this complexity. And so when I visit departments and I see something like this, I tend to know that Hopkins is the wonderful sort of conglomeration of small, but also having the resources that we need to get research done. One of the other ones I want to point out on the right, as you look through the list, is a 3D printer. So a lot of our faculty tend to work in material science. Again, that requires the latest and greatest machinery, and we have that available to us as well. So when you put together large amounts of research dollars coupled with small faculty, Hopkins is what you get. We have a lot of collaboration with a number of schools and departments outside of Johns Hopkins. So the list over here is extensive, and by no means is this list exhaustive. This is just an example of how we collaborate across public health, arts and sciences, international studies, medicine, as well. One of the ones I'd like to point out is the Applied Physics Laboratory. This is a unique center that Hopkins is part of Johns Hopkins and is part of also collaboration with the government as well. So being close to the Applied Physics Lab gives Hopkins resources that some of the other institutes and universities would not have. Some of the universities externally that we have collaborations with, again, not something that is exhaustive by any means, but these are the current most important collaborations that we have. So for those of you that are looking at other universities, if you want to get an idea of the type of research projects happening here, a lot of these universities share those research projects with us, and we have a lot of shared grants and shared projects that we do with all of them. We know that along with academic, one of the things you'll realize about our department if you go through our CVs is that almost all of us have worked in some type of industry before we joined Hopkins. So along with being sort of top of the line in terms of academics, we have very close collaborations with industry and government as well. Again, by no means is this list exhaustive, but a lot of these places are places we collaborated with before we became faculty here at Hopkins, but also things that we have developed and continue to develop research collaborations with as we try and make sure that our research is applied in the real world as well. Funding sources, again, the nice thing here is you'll see there's diversity. So not only do we get funding from the National Science Foundation and the Department of Defense, which have been traditional engineering funding sources, a lot of our students and the faculty also get funding from the NIH, the World Bank, and philanthropy organizations as well. So you'll find a wide variety of projects that are done in our department in civil engineering. On to our PhD program. So I'll give you the nuts and bolts first so you sort of understand what it's typically made of. The typical timeline for completion is around 4 to 5 years. The requirements in terms of coursework is 8 courses. The other requirements are very similar to other PhD programs. We have a department qualifying exam, which happens after the first semester you join the department. This is usually an oral exam that tests advanced undergraduate knowledge. Somewhere around your 3rd year, we have a graduate board oral exam. This contains faculty from inside and outside the department and is mostly meant as a check for your research progress and also making sure you're on time to graduate within our timeline. And finally, the last requirement is a thesis defense, where you write your dissertation and you defend it in front of a committee of faculty members. I want to point out 2 unique things to our department that often students appreciate. The first thing is advisor matching. So in a lot of departments, you get matched with your advisor in the PhD program before you show up. In our department, we want to give students flexibility. So the first semester you come in, every student meet with relevant faculty before they decide on who to be matched to. So students are able to start off in courses, they're able to discuss with faculty current projects before they match with the faculty that they want to work with. Now, by this, none of this is meant to say that you won't get the faculty you want to get matched with. In my experience, 70 to 75% of the time, students get their first choice of faculty. And a lot of times, if a student knows before coming in, I want to work with this faculty, the faculty also know they want to work with that student. Most of the time, that happens. 25% of the time, students are matched with their second choice faculty. So more than 95% of the time, you will be matched with one of your 2 first choices, and very rarely do we go on to your 3rd choice. But again, this is meant to give flexibility to both the student and the faculty member, and making sure that this matching happens for both parties involved. So you'll have a lot of flexibility when you come in. The other amount of flexibility that we give that I cannot stress enough, every PhD student, if they make satisfactory progress, is fully funded with stipend, tuition, and benefits, including healthcare. So if you're admitted as a PhD student, you don't need to worry about if you're an international student. You don't need to worry about if you're a domestic student. You don't need to worry about anything. We will automatically fund you for your entire time here as you make progress through the program. A lot of students will have questions about this, and I want to get that done from the beginning. And I'll repeat that again, because again, I know a lot of universities aren't doing this. You will be fully funded for your entire time here. So if you're looking for a funded PhD program, I highly recommend you apply to our program. If you get in, you will not have to worry about funding. I want to move on to our MSE program that's geared more towards making sure that you interact with industry, and also making sure that if you did want to use it as a stepping stone to the PhD program, you could do that as well. So again, we have 8 courses. There's 2 choices you can do. So there's an 8-course master's degree that's designed for you to come in and out of the master's program in a year. Some students take longer than a year, and that's perfectly fine. We have that flexibility in there for you as well. The other option, if you were looking for our master's program as a stepping stone to the PhD program, either here at Hopkins or at some other university, is we offer a 7-course plus thesis option, which is the research track. That allows you to develop some research experience as you're here at Hopkins, and then move on to research if you want to as well. One of the great things we offer our master's students is the opportunity to complete an externship during intersession. And again, with satisfactory progress and satisfactory matching, all our students for a week during winter break, which is intersession in Hopkins, so you get about 3.5 weeks off, we offer an externship experience where you go and work in an industry in your choice for a week. This experience we find is really good because, one, instead of having a full-blown internship, companies know that you're there for a week, they get you involved in relevant projects, and they get to know you really, really well. So again, our goal is to make sure you have the choice to go on to something right after your master's program. If you're looking to go into industry, as a lot of our master's students are, then you will have the chance to do this externship and then move on to your industry job after Hopkins. If you're looking to do research after this, we offer the 7-course and thesis track. And if you're looking to do both, you're trying to keep your options open. I was an international student when I first came to the United States. I wanted to keep my options open. You can do both, and that'll make sure that you're in line to have the flexible options once you graduate. I also want to point out in terms of funding, majority of our master's students receive some sort of financial aid. So again, I don't want this to be a deterrent for you for applying. So please do apply, and majority of our masters have some sort of financial aid at some point while they're here at Hopkins. Here's a sampling of courses. Again, not exhaustive by any means, just meant to show you, the depth and the breadth that we go into. So again, like I talked about, we're a small department. So what you'll see is we have very specific courses that you might not find in other departments. So advanced finite element methods, for example. We go really deep into that because Professor Somnath Ghosh is one of the leaders of that field in our department. At the same time, if you want to study something broad, from energy to healthcare to natural disasters to cold formed steel, that's offered in our department as well. We also offer evening online courses that are more suited towards students in industry or students who want to work in specific fields. So the courses that might not be offered regularly in our department, and on evening and online courses, you'll be able to find these more specific engineering courses that you might not find in our regular courses. So again, there's a large amount of options available to you when you join our department, and we try and make sure that you have the flexibility to get what you need and then move on to the next area you're supposed to go to. All right, so we'll move on to admissions now and get you a little bit through the process. And again, for more admissions questions, more detailed questions as you have them, you are more than welcome to reach out to us. So there's an online application. Usually in the application, there's a statement of purpose, 3 letters of recommendation, your GRE TOEFL scores, as well as your academic transcripts. Your deadline is December 31st, 2018. Your applications are reviewed sometime through January and February, and your decisions are sent out in March. All applicants will definitely be notified by April. And again, I want to point out 2 incredibly key things about our program. We're a non-traditional civil engineering program. We take students with physics bachelor degrees. We've taken students who are electrical engineers. We've taken students who are social scientists. Non-civil engineering majors are encouraged to apply both to the master's and to the PhD program. You are more than encouraged to do this, okay? So if you don't have a civil engineering background, do not worry at all. Our program, if you don't have a civil engineering background, but you're interested in civil engineering, this is the program to apply to. I really encourage you to apply to this program. The other thing I want to point out is that with a bachelor's degree, you can apply to our PhD program. You do not need a master's degree to apply to our PhD program. So if you're trying to decide between the master's and the PhD, there is an option to apply to both, but I would highly recommend you look at our PhD program and try to apply. A lack of a master's will not make you get rejected from our PhD program. As faculty of someone who reviews these things, I can tell you some of the most important things to us. All the things here are very important. So obviously the test scores are important, but we also look very closely at letter of recommendations and your statement of purpose. So make sure those are very carefully written and thought out when you put them in. All right, so I'm going to dive into research, and as typical faculty, I'll spend some time on this. So I hope to get you excited about what we do here. And what we do in this department really filters down to our courses, it filters down to our education programs, and it also filters down to the type of experience you're going to have in our department. So what is unique about civil engineering at Hopkins? And what I like to tell everyone, and what I see every day, is that our department is unique in that we work across scales. We like to tell civil engineers of tomorrow, and here's another phrase I like to use of the faculty, it's getting caught on with the faculty. I like to call it civilization engineering. So if anything that has to do with civilization, we have in our department. So we go from the very smallest molecule which is the mechanics and materials program. You see I've drawn an airplane over there, but you'll also see that every molecule in the airplane interacts with its environment and behaves in very, very different ways. That molecule at a very small scale influences how that airplane interacts with the environment around it. So again, think about that aspect of scale. How does the very small molecule lead to a bigger structure like that in terms of its function and its behavior? You move on to a slightly larger scale in terms of structure. So we like to say that our structural engineering program uses bottom-up fundamental physics. So we move away from ad hoc approaches to structures and say, how do we use the latest development in science, the latest development in engineering, the latest development in 3D printing to enable our structures to be built for tomorrow? So, again, our structural engineering program looks at a lot of traditional structural engineering problems in terms of disasters, but it looks at it through a very, very modern lens. And then finally, the systems program, which I am part of. So that goes to the largest scale of society. How do we realize our infrastructure in energy, in health, and in transportation? Where do we put that infrastructure? How does it function? How does all that infrastructure lead to better outcomes for society? Every day that I look at where society is going, I'm looking at the next generation, and they care more and more about what impact they're going to have in different facets of society that they're part of. Our systems program really fills that gap. So it takes you beyond thinking about this is an engineering structure, this is an engineering problem, and makes you think about, if I use my engineering skills, how can I make sure that it benefits society as a whole? And then I'll give you certain examples of that as we go on. So the mechanics and materials program. So as you can see, we have 5 faculty in this department: Professor Somnath Ghosh, Professor Lori Graham-Brady, who also is the chair of the department, Professor Jamie Guest, Professor Stavros Gatanaros, and Professor Michael Shields. So all of these faculty, again, the thing that combines all of them is that they work across scales. The other thing that is unique to all of them is they like to figure out how small molecules can impact larger structural function. So Professor Jamie Guest, right here, one of the cool things he does is topology optimization. And the way I like to think about it is that if you're building a structure or you're designing some cool architected building, you don't want to fill the entire building or the entire structure with material. You only want to fill very specific portions of it so it still maintains its structural stability. And so that's what his research is. His research is understanding where you need to put that material so you have something that functions well, but also is structurally stable. And if you ever fly through the Qatar airport and you walk outside the airport terminal and you stare up, you'll see that it has a very cool structural formation, and that's formed through topology optimization that Professor Guest has worked on. I'm going to turn it over to Max now, because he's going to explain this cool sort of mechanics of material example from Professor Somnath Ghosh's lab.
Thanks, Wale. So what we have here is we have a monopole antenna structure which couples electromagnetic physics with traditional finite elements mechanics. So what we can really see here is the interaction between 2 totally separate sets of really different fields. So we're not only is it multi-field, but really we have multi-scale here as well, because we're coupling small scale interactions and higher scale interactions. This can be used for any number of things, for damage sensors or for predicting how an antenna will operate under real world conditions at, say, like Mach 3 in an airplane. So this is just a prime example of how Hopkins excels at mechanical simulations. And if you really want to come and do high level work in this field, you should come to Hopkins, and we have various groups that will do these types of simulations.
Thanks, Max. And Max pointed out something that I forgot to mention. Remember those centers and institutes. Civil engineering is also home to the Hopkins Extreme Materials Institute, as well as 2 centers that are led by Professor Somnath Ghosh, funded by the Department of Defense. Both of these institutes work on problems like this that really support what our faculty and our students do. So moving on to one scale up in terms of structures. So again, we have 4 faculty in this area: Professor Ben Schaefer, Professor Thomas Gernet, Professor Chris Moen, and Dr. Rachel Sangri, who's also director of our undergraduate program. So we work on everything from traditional earthquake engineering to fire engineering to really understand how stochastic mechanics and structure reliability interact. Professor Ben Schaefer is actually a global leader in cold-formed steel structures. One of the coolest things that he's worked on that relates to my field is that he designs incredibly tall windmills made of cold-formed steel. For those of you that know a little bit about energy, the fastest winds are at incredible heights. So you need to build windmills incredibly tall. The problem with building a very tall structure is that it gets really heavy and really unstable. But using cold-formed steel, using the research that Professor Ben Schaefer does, he's actually received several grants to develop these really tall windmills. So 10 years later, when hopefully a bunch of us are receiving electricity from a bunch of renewable energy, part of it you can thank to Professor Ben Schaefer and the work that goes on in his lab. For other cool stuff that happens in his lab, I'm going to pass it on to Astrid, and she's going to tell you a little bit about what's happening in this slide.
Right, so this is a research project that my professor did a few years ago in cooperation with Buffalo University. It's about system behavior of cold-formed steel buildings, and we design a building of members, and we look at the members and design the whole building from the members. But with this research project, we found that the system behavior of the whole building is much greater than the member behavior when we break it down. So we found that the stiffness and the capacity of the whole building is about 4 to 5 times the capacity that we calculate from the members. So when we only look at the non-structural members, there's much less stiffness of the whole building. But when we add the drywalls to the building and the outer claddings and the windows, all of that adds stiffness to the whole building. And in this slide, we see an earthquake simulation of this whole MSE building at the maximum design of earthquakes.
Yeah, thanks, Astrid. Yeah, when I visited the department, this was one of the things that I was, again, like I said, non-traditional background, right? So I'm not a civil engineer, but the first time I saw this, I realized that civil engineering can do some incredibly cool things. This is a full-size 2-story building. This is an incredibly large experiment that Hopkins leads that rarely happens at other places. And what you can see here is that through a computer, they can pretty much simulate any earthquake you want over here. And that's something that I thought was incredibly cool and did not know about. Okay. Moving on to our largest area of research is the systems area, and as you can see, we have a little structure drawn there. We are in the Department of Civil Engineering overall. The systems area is home to the Center for Systems Science and Engineering, and we tend to work on a very broad area of research in terms of energy, health, and transportation. So some of the stuff we work on is energy infrastructure, so windmills that I talked about, but also natural gas and crude oil infrastructure, which I'll show you some examples of. Professor Agusa is currently working on the ethics of self-driving cars and understanding how they come into policy. Professor Lauren Gardner, who's a new hire and she'll be joining us in January, works on biosecure mobility. If you want to know what that means if epidemics are spreading around the world, how do we come up with policies that can stop the spread of very dangerous epidemics such as Ebola or Zika? So her research is in that area. And then finally, Dr. Kimya Gobadi, who's also a new hire, she'll be working on healthcare management and optimization. She works incredibly closely with the hospital to really understand how do we better cure head and neck cancer patients and how do we better manage patients that move through hospitals. So again, if you think about some of the broad areas of research here, you'll realize that we extend the breadth of civil engineering in our department, and we really use engineering principles to solve some of the most vexing problems in society right now. I'll give you a little example of something we've done. So what this graphic shows you is the number of accidents that happened from 2009 to 2014 for crude oil being carried on trains. And so what you'll notice is that as this graphic moves on, as the colors move on, it starts off very small in 2009, then grows in 2011, and then finally we see some incredibly huge accidents in 2013. So depending on which part of the United States you know, in Alabama, there was a humongous accident that spilled into the river. In Virginia, this spilled into the river as well, affected drinking water for close to 1 million people. And you'll see these are all over the United States. And I was approached by the Department of Energy, and we were asked, like, no one knows why this is going on, and no one knows how to stop this. Can we understand why there's so many accidents for oil on trains happening at once? And at that time, there was an obvious answer. The obvious answer was, well, suddenly the United States has started producing a lot of oil. When the country starts producing a lot of oil, we actually have no idea what to do with it. So what do? We put it on a train. Those trains need to travel to certain parts of the country. One is Cushing, Oklahoma, so in this region where there's big oil storage, but also part of it goes to the Gulf Coast where it's designed to either be exported or shipped to other areas, and also through Maryland where we are at Hopkins. So we set about designing a model that would help predict how could you stop oil on trains from being this oil on train problem from happening in the United States. And so one of the things you have to realize about the United States is that individual states have a lot of power. In fact, individual states are the only ones that have power to stop this particular problem. So not only do we need a model that helps us predict where the oil on trains will go, we need to insert some sort of game theory in there in terms of how states are going to develop policies to stop the flow of oil. So, and that's something we did exactly. So we developed this model that helped predict how we could stop less crude movement for going into California. Again, we picked California because we expected California to be the next big hub of these movements, and we expected California to come up with legislation that would stop this. And in fact, the answer, once I tell you, of how we would stop crude by rail movements to California, it'll surprise you initially, but at the other point, you might be like, oh, that makes sense. The answer was that it actually, California has to do very little to stop crude oil movements. What we really need to do, and we actually did, President Obama did this in the later years of his term, was allow the United States to export crude oil. In the time of Jimmy Carter signed this legislation that restricted the export of crude oil from the United States to improve national security. However, in the world we were in today, where we had clearly too much, removing that crude oil export ban was incredibly important. And again, we could not have come up with showing the Department of Energy this, and in fact, we were in close touch with the Department of Energy when we were building this model. We could not have done this had we not designed this incredibly bottom-up, game-theoretic, optimization-based engineering model that interacted across scales to understand the impact of a policy like this. And so, and now, as you all know, there's another policy we have to think about in terms of crude oil. Now we're in the danger of exporting a little too much. So how do we get around that, and how do we move to a society where we're using less and less fossil fuels? All right, so I'm going to start on the student experience now, a little bit once we're done with research. And as I do this, I'm going to try and transfer on more to the students, because they can talk a little bit more about student experience than I can. So I'll ask them to jump in. So you all should excuse them if they take a little bit of time to jump in, but I'm sure that they'll be really excited to talk about things. This, by the way, is, if you know what Maryland is known for, it's known for crabs. I had no idea how to even eat a crab as it came out steamed and full of spices. An undergraduate named Stuart Walters was like, oh, professor, let me just show you how you do this. And he explained it to me, and the disdain with which he talked to me, he said it was revenge for all the time I taught him prob stats. But it was great. I got to eat a lot of delicious crab as that went on. So Baltimore. So Baltimore is ranked as the second best food city in the United States in 2015, and I will attest to that. Baltimore is one of those cities where you can still find the mom and pop food stores inside the city. Every other major city in America, they have moved out into the suburbs. If you go close to Penn Station, right around the corner is a wonderful Korean shop that serves breakfast, they serve lunch, and they serve the best bulgogi that I've at least had on the East Coast. Baltimore is also a big hub for startups. So along with what the Whiting School of Engineering is doing in terms of fast forward and establishing real nice making spaces very close to campus, Baltimore itself is booming in terms of the number of startups. One of my undergraduates who actually worked on that crude oil model that you all just saw currently works for a startup in Baltimore looking to advance cellulosic biofuels. So this is something, again, that's very real and very, very relevant to Baltimore. Baltimore also has a big history. So if you, DC and Baltimore often get compared, but for the music affogatos in there, the Baltimore Symphony Orchestra is way, way above the National Symphony Orchestra when it comes to talent and when it comes to when people coming from the outside to look at it. Along with that, there's Artscape, there's the Baltimore Marathon for the sporty types, and then there's 2 major league sports teams, which me, again, not being from the United States, got to learn about football and baseball once I came to Baltimore. There's a lot of outdoor recreation as well. It's a great thing about Baltimore that you can step out and within 5 minutes you're in complete forest. In fact, Dr. Ben Schaefer, who I showed you in the previous slide, the one who developed really tall windmills, one of the other things he does is that at 10:30 every day, he takes a group running, which is called the Hopkins Harriers. And they go on a run, all the way through these wonderful state parks and wonderful sort of recreation areas around the city. So it's a wonderful way to sort of exercise in the middle of the day, also get to know your professors. I'm not a really fast runner, but when I join them, they slow down to make sure that I keep up. All right, so I'm gonna turn it over to the students now. In terms of how it is to live. So the Remington area of Baltimore that's up and coming, you can see that. They don't have to talk about that. Work, that's Misha. And then right behind him is our 3D printer, and also some of our student activities and organizations.
Let me start with SEGA. SEGA is the Civil Engineering Graduate Association that is the main host for student activities after work. So the picture on the right with all the people is one of the SEGA events where we went to, we have 2 events, big events, one in the fall and one in the spring, where we go to a park and go hiking a whole day. Or in the spring, we went to Six Flags amusement park a whole day. We have movie nights, we have barbecues, we have coffee hours. It's a good way to get the whole department together and relax over something else than work and get to know each other.
Hopkins also has a lot of events that take place on campus. Every year we have Spring Fair, for example, which is basically this big event thrown by Johns Hopkins, and there are artists that come. There is a beer garden there. It's really a wonderful event that the whole campus essentially just turns into this giant fair for a whole weekend. Also, Baltimore is just a great place to be a 20-something-year-old. Baltimore is a little bit overbuilt for the population it has, so housing's pretty cheap. There's a lot of nice neighborhoods right around Hopkins. And so there's always things to do. There's always people you can meet that are going and doing things. So you never have a boring or dull moment, really.
Great, awesome, thanks. One thing that I am really proud about our department, and something that was born out of the faculty once the students said so, is that the Whiting School of Engineering, the engineering school as a whole, has a lot of career support and has a lot of contacts and a lot of preparation for you to go on to your next step. But the department itself, every year, has its own department career fair. And again, if there's any qualms of you all thinking that you're coming to a small department, this should remove everything. I challenge you to come up with departments who have their own department career fair as large and as diverse as the one we have. We get a lot of industry to come every year, and our students get to interact with all these companies. In fact, the number of companies that come to our career fair is going to be larger than the number of master's students and PhD students we admit in that class. So if you want to think of something that has opportunity and the fact that you're going to come in and you're going to get lots of one-on-one, not just with the faculty, but with all these companies that are coming in, it opens your world up to a ton of opportunity that you would not get anywhere else. It helps you unpack your own strengths and then really tune them in to what you're looking for. If it's okay, I'm going to pick on Enze for a little bit because he's a master's student. And one of the things that comes out of our master's program is the externship that I talked about earlier. And then Enze, I believe you did this externship back in January, right? That went on for a week. So I just want to tell everyone a little bit about what that externship was and how your experience was.
Yeah, actually, as you know, it's pretty hard to get support from a department if it's pretty big, but in our department it's pretty small, so our advisor can get us connect to those company in their internship. So my advisor found a company in Baltimore. For me, it's a structure company, and most of also have the transportation. So I went there for the externship. So it's pretty great experience because I haven't get in touch any job in American and internship, and that helped me learn a lot about the work in American. So if you are thinking to having more connect with industry, you should think of Johns Hopkins, because if you are going to find your connection, your resource by yourself, it's pretty hard, but you have a lot of opportunity here in the department. The advisor and those companies can help you a lot.
Thanks, Enze. And Enze spoke from the perspective of a master's student, but I also want to say a bunch of our PhD students also go into industry. We have an equal division of academia, government, and industry from where our PhD students go. And that's what I'm going to talk about a little bit now in terms of our civil alumni. So academia, and so these are just, again, not an exhaustive list at all, just so you know where we send our students. So we send them to assistant professorships at all these universities. And the asterisk highlights international students in terms of where all of them have gone. We also send, and so you can see that there's a full length here of assistant professors, lecturers, and postdoctoral fellows of where our alumni from our PhD program go to. In terms of government and military, so again, U.S. Naval Academy, but also we have a bunch of connections with all these these research laboratories, both government and sort of semi-private research labs. So you'll see that we send our students to a wide variety of places in terms of the government as well. And then finally in industry, and this list is big, and again, by no means exhaustive, but if you're looking to go to a traditional engineering firm, then you can sort of look at, we send people to Thornton Tomasetti, but we also send our students to places like SpaceX and then places like Apple as well. So these are really up and coming companies where at Hopkins, again, because of our diversity of research and because of the type of stuff we teach you, we can really send you off to a number of places. All right, that is towards the end of our online webinar. Sorry, I lost the words for that. You can imagine that happens if you're talking too much. The easy words don't come easy. I'm gonna let you ask questions, but I'm gonna just like warm up a little bit of the questions I've gotten a lot through email. One of those questions, which I also pointed out, was about civil engineering and like, oh, I don't have a civil engineering background. Can I still come to this department? And I'm going to pick on Charalampos right now, and he's going to tell a little bit about his experience because, like me, he never took a civil engineering course in his life. So go ahead, Charalampos, and tell tell everyone a little bit about what your experience was coming into this department.
Yes. So I came in with studies in electrical engineering, which was my first degree, and then my second degree was at a business school. I did operations management. Regardless of my background, first of all, I still got accepted here, and it seems to me that, in fact, many faculty actually look for this diversity in the background. So my experience so far has been more about navigating what I am interested in and navigating this both within the department and outside the department. So my first 2 semesters, mostly my first semester, I was able to take courses from economics, from electrical engineering, from applied mathematics, which really touch upon my background coming in. So my experience so far has been this freedom to explore what I am interested in and better tailor it to what the department needs and actually bring in something new.
Yeah. Thanks, Carlampos. Yeah, that's it's been great, and I encourage you all to sort of look at that, sort of look at this experience and coming into our department as a very, very welcoming place for all types of ideas. As long as they're new, innovative, and you're willing to work hard, you can get anywhere you want to from our department. All right, so I'm going to go on now down the list in trying to answer some of these questions. Please go ahead and type them in. If there's any other questions we don't answer, again, we'll send you through an email after that. So, and you have our contact right here. Contact me anytime, contact anyone anytime. We're a very, very friendly group, all right? So please do reach out to us in terms if you have any questions. All right, so we're gonna go through some of these right now. A bunch of you are asking about minimum GRE and TOEFL scores. I'll say right away that we don't have any minimums that we look at in the department. You should apply if you believe you're a good fit. Obviously, we do look at them, and it's important to have a good score, but we look at the whole package. If you're applying for the PhD, I want to know how you think. I want to know, and you can do that through your statement of purpose. And you can say, hey, I'm not great at solving those GRE questions, but you know what? I can come up with an amazing research problem. Yes, make sure your GRE is good, but don't just worry about that. There's tons of places in your application you can do well. The other thing that the students have pointed out that are also very helpful for international students is that we also accept IELTS scores. So not just TOEFL, but IELTS is also accepted. The other question is, are professional references okay? That's perfectly fine. We take professional references both in the PhD and the master's program. Again, we want you to do the best work here. So whoever can tell us that you are able to do good work, that's what we need to hear from. So professional references are perfectly fine. Can I submit all professional references? That is also okay. I recommend, though, if you are applying with a PhD program, that you at least have someone to talk about your academic abilities. A professional reference that can talk about your academic abilities is also good, but for the PhD program, we'll need that. For the master's program, it matters less. You can submit all professional references. So again, people asking me minimum GPA requirements about themselves. Again, I encourage you to apply regardless of your GPA. We don't just look at that, we look at all facets of your application. Is there a mandatory limit to your CV? Nope, no mandatory limit to the CV. In fact, if you look at academic CVs, they tend to be pages and pages long. So put all relevant stuff on your CV. Don't put stuff that's irrelevant. I don't need to hear about certain things you did in middle school or in 5th grade. Extracurricular activities are good. I want to see that you're a rounded individual, especially in places that you've had leadership. So if you were in charge of a student group when you were in your previous location, or you have experience sort of leading certain other groups, please do mention that. What if I cannot receive my GRE scores? Submit whatever scores you have through the application. We can contact you for your official scores later if you are under consideration. All right, so there's a question about that we're working on shake table tests for self-centering frames and design of infinite walls on these frames. I wish to switch to systems. Do I have a chance without experience of systems? Yes, you do. Again, we accept any and all students with every and all backgrounds. We will train you here to do what you need to do. What I like to tell students is that if you have a good math background, you have a good background, somewhat background in computing, and you're willing to work hard, that's really what we're looking for. Another thing we look for is if you can write well in the PhD program. So make sure your statement of purpose is well written, and make sure there are no errors in that statement of purpose. Okay, let's, application fee waived. I'll let Lisa answer that. Master students have opportunities for research assistantships. Yes, in fact, Enze, you're doing a research assistantship right now, correct? Yeah, and so yeah, master students definitely have opportunities for research assistantships. They can be paid or for credit, and you can talk about that once you come to the department. Again, when you're a master's student, we want to make sure you go to where you need to go. If it's research, we'll get you a research assistantship. Okay, pursuing a master's degree. Currently pursuing a master's. This is a very specific question about extension to master's degree. Please email us and we'll get back to you on that particular question. Let me try and make this system work for a second. If you have no prior research experience, yes, you can still apply to our PhD program. In fact, I encourage you to apply. And again, we want to see how we want to see the whole package and how you think about research and if you're passionate about it. How many? Oh, this is a good question. 8 courses in the department. How can be different department of the writing school? You can take as many courses you want as long as they're graduate level courses. You can take engineering courses, you can take public health courses, you can take arts and sciences courses. Harlampos took pure math courses and courses in the economics department. I had a student that took courses at MICA, which is the Maryland Institute College of Art. You are allowed to take a broad variety of courses from everywhere at Hopkins. Research experience is not crucial in getting a research assistantship. You can get that from, and sorry, I went a little quick in that. The question was, is research experience crucial for getting a research assistantship? No, it's not. You can get that here once you join. Yes, you can take courses in computer science. A lot of students do that. A lot of students, I think almost more than half, take courses in computer science. You can definitely do that. Hopkins, like I said, Hopkins is a very collaborative place. And because it's so small, you can move pretty much to take courses and to get experience in anywhere once you're here in the Department of Civil Engineering. Living expenses in Baltimore. You know, those, again, I think I am not an expert on economic sort of things, but I'll make sure Lisa gets you those information after that. And yes, there are research assistant, teaching assistant opportunities in the department. Next semester, I have a mixture of PhD students and master's students who are going to help me TA probability and statistics. I have heard that Johns Hopkins lacks in experimental work in civil engineering. Is it true? No, I will disagree with that. Do we have as much experimental work as a place like the University of Maryland College Park? Probably not, because they have, you know, probably 30 people working in experimentation. Our department has around 3 faculty, our department has 3 to 4 faculty who work in different areas of recommendation. And not only that, they collaborate with a lot of experimental work faculty. So in my experience, what happens is when you come here, and if you want to do experimental work, you will find faculty who do that, or we will make sure you get in touch with faculty at the department that are doing experimental work as well. So lack is not the right word I would use at all. In fact, the first thing I showed you was the big blue baby, and we also showed you a video of a shape table of a building 2 stories large. And Astrid's going to add.
In Buffalo, though, but we were there. We were collaborating with them. We were there building it and executing the tests. And right now, my project is at both at Virginia Tech doing tests and at Northeastern University doing tests at both places. And we are in on the live streaming of the test when the big test is running. And we hear updates on the test all the time.
Wow, nice. Okay, and then expectation for number of PhD students. I can't give you a number. That depends on faculty needs and our applications. I can tell you it will be somewhere around 10 to 15. We won't be admitting 40 PhD students. Okay, so if you have a degree in the United States, an undergrad degree, can you waive your TOEFL score? This is something we'll get back to you on that. I know that's something a lot of other universities do, but we'll definitely get back to you on that. Okay, do we need separate GRE grades from? No. The general test is sufficient. You don't need to take the subject tests for the GRE. No physics and math subject tests. The general GRE is perfectly fine. If you want to take one and give us the score, that's fine too. Again, a specific GRE score question, I'm not going to give you a minimum score because, again, we admit a wide variety of students from a wide variety of backgrounds. So we want to make sure that that everyone who's interested applies. What portion of the student body receives financial aid? So PhD students, everyone is funded. Tuition, and you get a stipend. You get a living stipend, and you get benefits, healthcare. So don't need to worry about that. Masters, like I said, almost all of our master's students receive some sort of financial aid for some portion of their time here at Hopkins. I think I got through all of them. Sorry if I was talking a little too fast, but I was being given warning signs that my time was about to run out. We still have a couple of minutes. I'm happy to answer anything, any other question. I'm trying to think. I'm looking to my students and anyone. Is there something I forgot that is really key to our department?
It's a really good department.
All right, and we had one more come in, question come in, one final one. Asking about publications, but no lab experience. Yes, you can apply. If you have, and if you have programming, yes, almost all of our students do programming. All my students do programming. You can use your programming here. We had someone go on to get a programming job at LinkedIn right after this. So yes, you can use your programming skills. Okay, and we're coming up towards the end of our time. I want to let everyone know that this presentation is being recorded, so it will be available to you online at a later time. And then if you have any more questions, please reach out to any of us, and we'll be happy to answer them or direct you to someone who can answer them. So thank you all for attending. I really appreciate it, and I look forward to all your applications.